Welcome to Spring LIB.
In this question, given data is there is a figure given. So first I will draw this figure. So in this figure there is a hard surface given, and on this hard surface there are two block is given. So first block having mass that is given in the question, that is 2 kg, and similarly second block is having same mass, that is 2 kg, and there is a spring is attached to second block. And now in the question it is saying that initially they both are rest, but after some time this first block is going in this direction with the velocity that is given 1 meter per second. So in the question it is asking that we have to find the maximum compression of spring, and in the question the spring constant is given, that is equal to 100 Newton per meter. So this data is given. Now let's start answering this question. So in the answer I will say that the mass of block is, first block I can say that mass will be written as, that is Ma is equal to 2 kg, and for mass of second block, that is Mb, will be written as, that is 2 kg. Now initial velocity for first block will be written as, that is Va is equal to, that is 1 meter per second, and initial velocity for second block will be written as, that is 0, because this second block is I can see that is Vb is equal to 0, because the second block is, you can see that it is at rest position. So here I had written the value that is equal to 0. Now in the question spring constant is given, that is K is equal to 100 Newton per meter. So now next step is, as you see in the figure, this first block is trying to move with 1 meter per second in this direction, and taking a collision with second block which is initially at rest position. So after collision, the first block for first block the velocity is going to decrease continuously, and at instant of time the whole system, that is first block and this spring and this second block, moves together with common velocity, that is I can say that is considered capital V. So I can say that here I will write, that is after the collision whole system, that is first block plus spring plus second block moves together with a common velocity, which I say that capital V. Here I had assumed this. So now next step is, here I am using the law of energy, conservation of energy. So apply the law of conservation of energy, that will say that total kinetic energy before collision will be equal to total kinetic energy after collision plus spring energy. So the left side will be written as, that is total kinetic energy before collision, that is half Ma MAVA square plus half MBVB square is equal to half MAV square plus half MBV square plus spring energy, that is half kx square. So now simplify it. So here x is a compression. You can understand that here x is a compression of spring when the first block is trying to collide with second block. So now next step is here substitute the data, then it will be written as, after substituting I can say that the left side will be written as, that is half multiplied by MAVA square will be, that is 2 multiplied by 1 square plus half MBVB square, that will be written as, that is 2 multiplied by 0 square is equal to half MA will be, that is 2 multiplied by, here in both term on the right side, for on the first both term I will take V square common, so inside will be written as, that is half MA plus half MB. So after putting the value I can say that half multiplied by 2 plus half multiplied by 2, and outside will be written as, that is V square plus half. Now k is given, that is spring constant value is, that is 100 multiplied by x square. Now simplify it, then I will get the equation, that is after solving 1 minus 2v square is equal to 50x square. So this is a equation number 1. Now as you see in the figure, there is a no external force is acting in horizontal direction. That means I can say that here momentum is conserved. So apply the second law, that is law of conservation of momentum. So according to this law, the next step will be written as, that is initial momentum will be equal to final momentum. So it means initial momentum, that is MA multiplied by VA plus MB multiplied by VB is equal to parenthesis of MA plus MB multiplied by capital V. Now simplify it by substituting the data, then it will be written as, after substituting the value, the next step will be, that is MAVA means 2 multiplied by 1 plus MBVB, that will be 2 multiplied by 0 is equal to parenthesis of MA plus MB, that means 2 plus 2 multiplied by capital V. Now simplify it, then I will get the value of capital V, that is equal to, after solving value is, that is half meter per second. So now I can say that this is a equation number 1 and this is a equation number 2. So by using this equation number 1 and equation number 2, the next step will be written as, that is here what I am doing is putting the value of V from equation number 2 to in equation number 1, then it will be written as, that is 1 minus 2V square, that means from equation number 2, put the value of V in equation number 1, so it will be written as, that is result is 1 minus 2V square means 1 minus 2 multiplied by half square is equal to 50x square. So now simplify it, then I will get the compression of a spring, that is X, is equal to after solving I will get that is X is equal to 1 over 10 meter, or I can say that in centimeter it will be written as that is X is equal to 10 centimeter. So this is the answer of given question, that is maximum compression of a spring will be that is X will be equal to, or I can say that X will be equal to that is 1 over 10 meter, or I can say that 10 centimeter. So I had solved the question completely. Thank you.